So we're looking at inequalities in two variables. This one asks you to graph the solution set. What type of inequality is this? Y is greater than or equal to 2x plus 1. Linear, quadratic, cubic, linear. So when you graph a linear equation, what shape does it make?
A line.
A straight line. So the first thing we're actually going to do when we have to graph an inequality is graph a boundary line, which is just the related equation. We're going to graph y equals 2x plus 1. And that's what it looks like. And you can graph it on your calculator. So go on your calculator and graph y equals 2x plus 1. It has a y-intercept of 1 and a slope of 2. It looks like that line. Once you have a boundary line, that shows you where your solutions are. They're either everything to the left, or in this case above that line, or everything below or to the right are your solutions. And so your calculator can tell you which region to go in. We're going to go and change that greater than, that equal sign to a greater than or equal to. On a TI-84 or something similar, you're going to go to y equals, and where you have that line in, y equals 2x plus 1, to the left, you see something like a slash.
Yeah.
Go over, put your cursor on that and hit enter. It changes it to, what, 3 dots? What it changes it to? Hit enter again. Now this is on a, not on the color. The color's a little bit different. If you're using one that's not a color, hit enter a bunch of times on that until you get a greater than sign, which actually looks like that. A triangle. A less than sign, I believe, looks like this. There's a triangle going the other way. So this is a greater than, this is a less than on a... So depending on your calculator, different ways of getting to this graph, but this is what you should see in the end once you have it graphed. What it means is that the solution are any ordered pairs that are in that shaded region or on that boundary line should satisfy that inequality. So if we just pick one randomly to try, can you give me the coordinates of a point that's in that shaded region?
4 and 3. Negative 4 and 3.
Negative 4 and 3. 1, 2, 3. I don't know why that's not working. I think it's not. Anyway, negative 4 and 3. Let's test it. So if we're testing that point, negative 4, 3, 3 is the x, 3 is the y value, right? So 3 is greater than or equal to 2 times negative 4 plus 1. I get 3 is greater than or equal to negative 7. Which is true. It should come out true if you chose a value in that shaded region. That's another way to check and see if you actually shaded the correct region too. I mean, you're using a calculator, so you should be shading the right region, but that's a way to check just by choosing a point. What's another point that's part of the solution set?
3.
3 and?
0.
Nope. 3 and 0?
Negative 3 and 0.
Well, 3 and 0 is over here in the white part, right? Negative 3 and 0 is?
Wait, Miss Bird.
Yes.
What if you flipped that?
If we look at the point 0, 1, that's right on the boundary line. And if I test that, 1 is greater than or equal to 2 times 0 plus 1. I get 1 is greater than or equal to 1. Is that true?
Yes. Yes.
Yeah, it's equal to. So that's kind of what that means when you have that shaded region like that. Here's another one that we'll look at. What do I have to do with this to be able to graph it? Put it in slope y-intercept form, right. Isolate the y. So I'll subtract 3x from both sides, and I get 2y is less than negative 2x minus 3. And then divide by 2, so y is less than negative 2 over 2, so just negative x minus 3 over 2.
Oh, yeah, so that makes sense.
Okay. So then I can graph that boundary line. And it looks like this, where the y-intercept is negative 1.5 and the slope is negative 1. But do you notice the difference with what I did here? Can you see that from where you are?
Yeah.
What's different?
It's done.
Yeah, it's a dotted line. Your calculators, the Inspire maybe does, but I don't think the other ones will do a dotted line. But it needs to be a dotted line. So even if you're using your calculator for graphing, if you're copying it onto a paper, make sure that you have a dotted line when, anybody know why this one's dotted?
Because it has
It's a limited divider.
Because it's not equal to.
Because it's not equal to, right. This one is just less than, not less than or equal to. So it doesn't include the points that are on the boundary line. Because those are the ones where it's equal. So then you shade and you end up with this graph.
Then we have to remember to do the.
Here's one more. Hey, what's different about this one?
It's quadratic.
It's quadratic. So what kind of a boundary line are you going to get? A parabola, yeah.
Is it either inside or outside?
It's going to be either inside or outside, right? So you do this exactly the same way. You're graphing the boundary line, y is equal to 2x squared plus 5x minus 3, which looks like this. Then put that inequality sign in there, the greater than, and you end up with it shading the inside, in this case, of the parabola. So all of the points that are inside or on the parabola itself, on the line, satisfy that inequality. The last one I have for you today,
Holy.
write an inequality to describe this graph.